standard deviation, how wide is your bell shape, your normal distribution, will be related to the average distance of your users to the hub. So you can make these funny extrapolations, and at the same time, in such an example, you can say, well, if my bell shape was very flat, had a lot of distribution, this means that the majority of your users will experience lousy access time. Well, perhaps you will have to put two hubs, two routers. That will be a possible solution. Another distribution, the chi distribution. The chi distribution mainly is very similar to the Gaussian, but the Gaussian basically, the normal distribution, you have a free and independent parameter. With the chi distribution, you have two parameters that are independent. I have put it here because a lot of phenomena that we have in performance are a lot of parameters, two or more. But usually at least you have one or two that are very, very, very important. So they will fit better a chi distribution. So you have your data, you adjust with programs, and you see, it adjusts better to a Gaussian distribution, to a normal distribution, or to a chi distribution. If it adjusts better to a chi distribution, then gotcha, you have more parameters. You don't have a single independent parameter, you have several parameters. That will be the example that I had put before, two independent the uniform distributions. Well, continuing with the scientific method, you need to adjust your data to the model. And your model to the data, of course. There needs to be a feedback loop between the results that you are obtaining and the model that you are trying to apply. Don't forget that the model should have some predictive capabilities. A model that is not able to explain future results is not a very good model. So you can say, okay, if you make the hypothesis, the database is the bad one, the culprit of all my problems, okay? You have gathered some data and it matches this hypothesis, perfect. And then you say, you extrapolate your model. If my database is the culprit, if I increase the size of my database by 300%, I will observe this performance degradation. The performance will degrade much more. You increase the size of your database, and the performance is the same. What does mean that? Your model is not able to do any prediction. This means quite surely that your model is wrong. You need to revisit your model. Okay? Realize that this technique helps us to identify bottlenecks. Again, we are dealing with very complex systems that have a hardware layer, have a network layer, have a software layer, etc., etc. All this will introduce a lot of performance bottlenecks. If you are obsessed only focusing in one possible putative bottleneck, you may be missing others. So please never be too attached to your hypothesis and your models. It can be dangerous. Okay, this is my summary. So the performance testers provide information, good software, good testers in principle. Good performance testing should be treated as experimental activity, and with all the time privileges that these should conserve. Performance testing in a rush usually is a bad idea. In tune with the scientific model, you need to make assumptions, design your experiments, and reduce the error bars, if possible, always that you can. Please don't be too attached to your decimals. I would say sometimes if you do automated tools, the automated tools are going to put you, I don't know, 20 decimal number. What is the meaning of that? I would say, you are telling me that your computer is able to measure time better than an atomic clock? No way. So be a little common sense. Analysis is in order to explain your model and feedback to your model. And your model may need to be changed completely. And for the reason, if they don't do a good job, well, change your model. Don't be too attached to it. The analysis, the ultimate goal of the performance, what it is to make the software better. And you make the software better providing enough information to everybody, both to the marketers that are selling the product, and they should manage the expectations of the customers, and also pointing the bottleneck to the database guys, to the software architect, to the developer, to everybody else. Questions?
So all this scientific formulas and so forth, are you having to do that yourself after collecting the raw data, or is the tool supporting you doing that?
Understand me, the normal and the chi distribution are completely run-of-the-mill. It's the most vanilla kind of distribution that you can find, and Excel does that.
Oh, right.
So you don't need to go.
Yeah, so the more complicated things, so you would have to say, oh, I see, that's more complicated.
Well, if you have more complicated, I don't use them because, well, we can complicate our life up to a certain point, and in a software development environment, always there is the time pressures.
Right.
Understand me, if I had a large budget and more time, I will go and buy Mathematica, for example, and then I will play a lot with the numbers, and I will try with other kind of distributions and so on.
Right.
But for most of the things, Excel is perfectly decent and available.
And if you the major drivers of the problem.
Yeah.
Because
you need to first of all capture the low-hanging fruit.
Right.
So if you are not going to, well, we can, but it's not our job, and I don't care, that if the SATA manufactured by HP or the SATA drive manufactured by IBM, there is a difference in access time. I don't care about that.
Right.
I prefer to attack things that we can control much better.
Right.
Usually, the performance limitations and bottlenecks are not at that level.
Yeah.
However, if you have lots of time and resources and tools, well, you will be able to start to identify the different, the variation. If you do your experiment very controlled, you do your test with the same system, and you change only the NAS. Right. Any variation that you will see, it will come only from the different parameters. And then you can start to elaborate, analyze, and make your model.
So the more common thing that you would be attacking would be that example of the Oracle optimizer when you put in different, or when you put in all your data in one bunch, then you found out, well, wait, it's below the 3 seconds when it's a simple query or a common query, I should say, and then it's above the 3 seconds when it's an uncommon one. So we have to go back and review our quality requirements around performance and see if that's acceptable. Or
yeah, that will be a possible solution. A possible solution. This means that the feedback, quite sure in this case, will be given to the DB group.
Right.
To the DB group. And then all the process will go to the system analyst and analyze how often, how many customers will be affected, and all these kind of things.
Right.
But this is a little bit beyond my role. It's other
Yeah.
people. The other thing is that it gets a moment that some things cannot be really solved. The Oracle optimizer problems is an optimization that Oracle does in situ in order to provide the best experience. But it means that some specific queries will be worse. It's the typical thing, if one shoe fits all, this means that nobody's happy.
So the marketing guys would fix that by saying 90% of the things will be below 3 seconds.
Yeah, well, what's happened is that the great majority of the users are happy. Yeah. And it will be only the users that are doing almost research, almost data mining, that are going to find these problems. And usually are the kind of users that they know that they are doing something essential. So, but again, this is not a problem. This is not the performance test problem.